In our video today, we're going to look at the economic advantages of MoorGuard protected mooring lines. And for our example, we're going to use the U.S. Navy. The class of vessel is going to be Destroyer. The U.S. Navy has been at the forefront of new, safer mooring line development since 1945 and are currently looking for the next development to make mooring lines safer, easier, and in the current financial climate less expensive. Pretty much the same goal as the rest of our MoorGuard customers. To understand today's safety challenges, it might help to understand the genealogy of the current mooring line system and the constant chase for ever stronger rope. After World War II, with the greater availability and lower cost of nylon, the Navy switched from manila lines to nylon. The new lines were stronger and rot resistant, but at a higher price. The big disadvantage had to be overcome was snapback, the tendency for high elasticity synthetic polymer ropes to stretch and break suddenly, snapping back with a dangerous lashing motion. The Navy mitigated this problem with the application of tattletales to all mooring lines to give a warning when the line was under a dangerous level of tension. Then in the 1970s, with the invention of Kevlar, the same material used in bulletproof vests, a composite line of Kevlar and nylon was invented that greatly reduced but did not eliminate the snapback behavior. Along with reduced snapback, the aramid lines are stronger and thus smaller and lighter and easier to handle. The disadvantage was a significantly higher cost, but the safety benefits outweighed the cost and the aramid line was adopted. The typical line configuration for mooring consists of 2 aramid lines per position. In an attempt to simplify the line handling activity in the 90s, the Navy began looking at the newest high-strength fiber, Spectra, another fiber also used for bulletproof vests. With the higher strength of the Spectra fiber, the Navy could go from 2 aramid lines with 96,000 pounds break each, a total of 192,000 on each position, to a single Spectra line with a 300,000 pound break. This switch allowed for faster cast-offs and for the Navy to use less line per mooring point. The disadvantage of Spectra is a significantly higher cost per foot versus aramid, but with the singling up and shortening of lines, the cost for each system is about the same. But the problem that still exists is with long lines, even new Spectra lines, there is still the potential for snapback. And the second, less obvious problem is cost. As long as we use ropes at 1/7 to 1/10 of their break strength, we're paying 75% more for rope we never use. As you can see in our other YouTube videos, the MoorGuard fuse makes overloading impossible, allowing you to significantly downsize the lines you use. Using a MoorGuard fuse in the standard Destroyer mooring line would allow you to reduce the size of the current Spectra line from 2 1/4 to as small as 7/8 of an inch and do exactly the same work, just safer. The only disadvantage is the line handlers will have to be trained to guarantee a MoorGuard fuse is added to each mooring point. Not exactly a disadvantage in the traditional sense. Here I recap the safe working loads of the aramid and Spectra systems. Regardless of the ultimate break, the safe working load should never be exceeded. Using the new Spectra lines, we have a starting point for our cost savings analysis of 42,000 pounds or 21 tons. Here I compare the relative cost differences of the aramid and the Spectra systems. As you can see, the cost per line after adjusting for the Spectra line savings makes the cost about the same. Here we can see that if we install a MoorGuard fuse, we can use a safety factor 2 with a Spectra rope when engineering our mooring line. This means we only need a rope with a break of 85,000 pounds. Doing the cost comparison of a 7/8 versus a 2 1/4 inch Spectra line, plus the cost of the MoorGuard fuse, we save over 50% versus the current system. In addition to that savings, the MoorGuard fuse will never allow overloading, preventing snapback and other potential deadly events. Let's scale that analysis up to ship level. Figuring on 1 bow, 1 stern, 2 breast, and 2 spring lines, and 6 MoorGuard fuses, you get a ship cost of $17,000 versus a current cost of almost $50,000 for a savings of 65% per vessel. And now for the good news if you're into cost savings and simplicity. With the MoorGuard fuse taking on the tasks of safety and shock absorption, your choice of mooring line is completely inconsequential. Polymer type, polypropylene, polyester, nylon, inconsequential. Type of rope, 3-strand, double braid, doesn't make a difference. The MoorGuard does the work. Therefore, you can do the same job with everyday rope, and in our example, that's a 2 1/8 inch 3-strand nylon available everywhere at low cost. As you can see in the example, your total cost for the system is $12,000 vessel, or a savings of almost 75% versus your current system. MoorGuard. Problem solved, money saved.